Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face Trending List, published on July 4th, 2025, about 5 days ago. This paper introduces a new framework for refining pre-training data that gives models up to a 7.2% performance boost on key benchmarks. The paper is titled RefineX, Learning to Refine Pre-Training Data at Scale from Expert-Guided Programs. And the way it improves data quality while avoiding common pitfalls is quite clever. The authors tackle the trade-off between effective data cleaning and efficiency, proposing a new way to surgically edit text at scale. Alright, so this first figure really visualizes the core idea. At the top you see the pipeline. Raw text goes in. A small refined model generates a simple program of edits, and out comes the clean text. The key innovation, shown at the bottom, is how they create the training data for that small model. Instead of asking a big expert LLM to write the editing program directly, which can be unreliable, RefineX has the expert first clean the text. Then it simply compares the original and the clean versions to create a perfect deletion-only program. Building on that idea, this diagram lays out the full two-stage process. On the left, during training, an expert model refines some seed text. Then, a minimum edit distance algorithm, which is just a way to find the simplest set of changes between two texts, compares the original and the refined versions. Crucially, it only keeps the delete operations, turning them into simple command programs. This clean data then fine-tunes a small base model. Then, on the right, this newly trained efficient model can generate these simple deletion programs for a massive dataset. This table then details the exact commands that make up these simple programs. It's a very short list. The model can use remove lines to delete a whole block of text, or remove string to take out a specific phrase from a single line. And if no changes are needed, it just uses keep all. By restricting the model to only these three very precise deletion functions, the whole process avoids introducing new, potentially biased text. It's a key part of how the framework improves data quality without creating new problems. Moving to the results, this plot really shows the payoff. On the vertical axis, you have average performance, and on the horizontal, the number of training tokens in billions, which is just the amount of data the model was trained on. The blue line at the bottom, labeled raw, is the baseline using unfiltered data, and the purple line at the very top, proxd plus RefineX, is the new method. You can see it consistently outperforms all the others, showing that the model learns more effectively and achieves better results with the same data. And this table gives us a much more detailed breakdown of that performance. The rows show different data filtering methods, from raw, unfiltered data to various rule-based and LLM-based approaches. The columns are different downstream tasks. These are just specific benchmark tests, like question answering, that measure the model's capabilities. And what you see, especially in that final average column, is that adding RefineX consistently pushes the scores higher. The bold numbers, which mark the best performance overall, are almost all in the RefineX rows, hitting a top average of 44.7%. Okay, so this table gets to the why behind those performance gains, and it's all about safety and reliability. What we're looking at here is the number of new words each method adds to the text it's cleaning. You see the end-to-end generation method, which just rewrites the text. It adds a lot. The other method, proxd, adds a few, but the RefineX row is all zeros. It literally adds no new words. This is the deletion-only constraint in action, proving that it successfully avoids injecting any new, potentially biased content. So to wrap things up, the core idea of RefineX is a clever two-stage process of distillation. Distillation, in this context, is just a method where a large, powerful expert model teaches a smaller, more efficient one. First, the expert cleans the text. Then, instead of just copying, the system creates simple, deletion-only programs from those edits. This gives the smaller model a perfect, safe lesson on how to improve the massive amounts of pre-training data these models learn from, leading to gains of up to 7.2%. That's all for this week's AI Research Roundup. Thanks for tuning in.